Excellent. One reflection, actually, when to the question about general purpose technology. Remember, Jean-Philippe at a moment said, hey, we'll see if machine learning is going to be like the internet. So if you think about the internet, it unleashed waves of change, social media, sharing economy, e-commerce. And so, I mean, one of the hallmarks of a general purpose technology is those sort of waves of different things, like electricity. Okay, we're going to stay on this theme of big tech companies, and we're going to shift over to Google, specifically the Google Launchpad Studio. So we heard earlier about setting up digital factories. This is actually one of the key initiatives within Google in that space. So this is based in the Bay Area, and it really matches up startups with the best of Google in terms of the technology, the people, the know-how. And arriving this morning from San Francisco, we have Malika Cantor. Malika she's the global lead on Google Developers Launchpad, so part of the team there. And besides her passion for AI and startups, she speaks 5 languages, so at home at an INSEAD audience, a BA in Chinese Studies from Cambridge, and an MBA from MIT. We'll forgive you that. Welcome Malika on stage. Malika.
Thank you. Hello, everyone. How's everyone doing? Good. How many of you are also jet lagged? Not too many. Okay. All right, so I'm here to talk to you about applied machine learning. I'm going to start by telling you a little bit more about myself and then about what I'd like to cover in this presentation. So my name is Malika. I'm a global lead on the Google Developers Launchpad team, and that is effectively the accelerator engine of Google. So we run initiatives all over the world, focused on accelerating innovation and specifically working with startups. Before I was at Google, I was a venture capitalist in Silicon Valley in San Francisco. I started a firm that focused on investing on early stage AI and robotics startups, and we were looking to disrupt traditional industry. So a lot of the themes that came up today, those are the kinds of companies that we were backing. Before that, I built a few companies and helped other people build companies in China, Singapore, Toronto, London, and then I made my way to Silicon Valley. So that's a little bit about me. I think you'll find a lot of me in this presentation, but what I'd like to cover is basically a bit about Google and the Launchpad program, and then focus on applied machine learning. And you'll notice that I use the term machine learning interchangeably with AI. That's something that we do at Google. We don't actually differentiate those things at this stage, but let's get in, and then we will go from there. So, Launchpad. Our mission statement is to empower startups to build and scale great products and companies with the best of Google. That includes Googlers inside the company, the network that we have with venture capitalists, universities all over the world, our thought leadership, so the best practices that we build inside the company, and our technology, so Google Cloud, TensorFlow, all of the tools, Android, search, that you probably know about. Our vision statement is to democratize startup success by building and organizing startup thought leadership and making it universally accessible and useful. How many of you know the vision statement of Google across the board? It's to organize the world's information and making it universally accessible and useful. And so what we're doing at Launchpad is we're trying to make startup success as democratized as possible. The team that I sit under, developer relations at Google, their goal is to build the 50 next Silicon Valleys in the world. We don't want people to have to come to Silicon Valley to build successful companies. We want them to be able to do it from anywhere. So as you can see, our headquarters are in San Francisco, but we've already built quite a network of programs all over the world. The green dots, even though, so when I joined a year ago, I built the program in our headquarters focused on supporting AI and machine learning startups called Studio. We've actually, I'm now supporting 6 other programs where we're working with AI machine learning startups. So in Sao Paulo, Tel Aviv, Lagos, Bangalore, Singapore, and Tokyo. So if you're working in one of those areas, would love to connect. Actually, I love getting to know my audience a little bit better. How many of you have a startup already? Can you raise your hand? How many of you are planning on starting a company? And how many of you are planning on leveraging AI in your company? I feel like more hands came up, even though the startups. Okay, Good. So now, zoom out from Launchpad and talk a little bit more about Google. As I'm sure you're aware, I think it was in March 2017, Google announced that they were an AI-first company. And then soon after that, they said that their vision, as of now, was to democratize access to AI. And we very much fit in that vision, but you can see that every other product and company at Alphabet is also aligning with this. So from our assistant that uses natural language, speech recognition to understand the meaning of different questions, the tone of your voice, to Google Home, Google Lens, Google Photos, the list goes on. The logos at the bottom, I don't know if many of you will recognize, but they're actually the companies under the Alphabet umbrella that are also leveraging machine learning in pretty radical ways. So DeepMind is trying to advance general artificial intelligence and do a lot of work in healthcare, so does Verily. And then Waymo is our self-driving car company. So this is actually not a Google slide. This is IP that I developed with my co-founders when I was in venture capital. And I hope it's a helpful framework to you to understand where we are when, in terms of applying machine learning to industry and applications. So the way that I like to explain it is if you think about every single technological development to have been a wave, we talked about waves before, of infrastructure followed by a wave of application. And so you go back to the 1980s, actually my father, who's in the audience, was working in this space at the time, satellites, telecom. That was the infrastructure development of what we know as digitization infrastructure. Then that was followed by one of the biggest applications we've ever seen in our lifetime, the internet. You fast forward to the 2000s, mobile infrastructure was being built. So wireless carriers, we had smartphones, lots and lots of sensors and electronics becoming smaller and fitting in our pocket. GPS capabilities, cameras are becoming more and more powerful. And then by the 2010s, we have Candy Crush, WhatsApp, Google Maps, a wave of application that gets built on top of that. So I think you get my gist. Today, I believe, and I think a lot of people in the community believe, that we're firmly building AI and machine learning infrastructure. The thing is that many of you, as well as myself in the last few years, are also working on the applications. So we're somewhere in the middle of those two last boxes. And that presents a huge opportunity, but also a ton of challenges, which I'm going to talk about. Because I like thinking in analogies. If you think about it, we're driving a bus, but we're building the bus at the same time. The tools, the infrastructure isn't quite there yet to be able to scale. We talked about scale. In certain cases it is, but in many cases it isn't. And I'll talk lots more about what we're finding at Google on that topic. So to talk a little bit about this infrastructure and where it's at, the way that my team conceptualizes the tooling around AI and machine learning is in these 8 broad categories. If you're building a company in the space, you probably aren't leveraging all of this. It really depends what your use case is. So if you're working on the hardware side, you might integrate some TPUs, some TensorFlow processing units, which allow you to do a lot more compute, but quite unlikely. You're probably going to leverage more resources that are connected into the cloud, like the Google Cloud Platform, AWS. We've also got these open source libraries. How many of you have heard of TensorFlow? Okay, good, great. So the most popular library for building your own machine learning models from scratch. There's also APIs that are being offered, so that allows you to build a machine learning model without building it from scratch. There are these pre-trained models that you can use. There's also these Cloud ML Engine is another tool that allows you to build things semi from scratch. There's marketplaces for algorithms and data sets. We've also got flexible tools, so if you have to keep some data on-prem and then only move some of it into the cloud, there's lots and lots being built here. And then also something that I'm extremely excited about is bringing machine learning onto the edge. So that's onto the phone, onto the sensor itself. Imagine if you can do inference on the device so that you don't have to move the data in and out of the cloud. It's both interesting from a cost perspective, but also obviously from a security perspective. Given that we're in Europe and GDPR is catching on so much, I think that bringing machine learning onto the edge of the network is actually going to be one of the most revolutionary things that happens. The other things I included on this slide are resources that are educational in nature. And one thing, I don't know if it's that hard to believe, I think you heard my background. I don't have a technical background. I'm entirely self-taught. And so I learned how to code Python on Coursera, and I learned everything I know about AI on Udacity. And one of the reasons I bring that up is I want to empower all of you, no matter what your background is, to go and learn this. It's not as hard as you might think. So now we've talked about the tools and the infrastructure. We can think a bit about some applications, and there have been a lot that have been mentioned today in the energy space, financial services. This is just an overview of some of the companies I've worked with in my career. I haven't put their names up, but you can see things from medical imaging all the way to smart grid, energy optimization, development of new products, and smart lending, sort of you name it. The biggest point I want to make here, though, and I don't know if you can see the image, is that right now we're only seeing the tip of the iceberg. So to echo some of the things that were said before, this is a revolution that is happening, and really the only inhibitor that we have is the fact that the tools aren't quite there yet. And so companies like Google and IBM and Amazon and other startups are also contributing a lot to building better tools so that this revolution can really come to fruition also in a secure, private, transparent way. So in my time at Google, I've worked with probably about 250 startups. Before that, a few other hundred. And all focused on this space of applied machine learning. And one thing that just has kept on happening is I get the same questions. And if you think about what it used to take to build a company and the process, in a lot of ways I see that falling apart. So the idea of iterating on an idea, experimenting, prototyping, scaling, there's a lot of new considerations, and I'm sure many of you know what I mean. Collecting your first data set is extremely time-consuming and costly. Convincing other people to give you their data might not necessarily give you an edge, because why would they give you their data and not give it to someone else? The sort of questions come, the same ones come up again and again. How do I convince my customers to allow me to move their data into the cloud? A lot of it focuses on data, and so this is sort of the point here I'm trying to make, is we are seeing new types of challenges. Traditional software companies didn't necessarily have the same questions. And to prove my point, I'm actually going to share some data from inside Google that we've started to publicize. And this is based on surveying all of the startups that I've worked with, as well as other AI practitioners. And we call it the ML surprise. So when you bring a model into production, there are 5 main things that you have to think about. You have to define the KPIs, the metrics that the algorithm is going to try to optimize for. That sounds kind of like product development too, but you want to do it specifically for the model. You need to collect your data, and not just collect it, right? You need to clean it, organize it, structure it, label it. You have to build all of the infrastructure that supports the model. So what is going to query the data set? How is it going to feed into some kind of UX that is facing your customer? You have to optimize the algorithm, and you have to also integrate it, especially if you've got hardware components or things like that. So this is what people thought when we asked them, in terms of 100% of your time, if you had to slice it up and tell us where you think your time is spent. This is not actually just, when we talk about effort allocation, it's not just time, it's also money. So you can see that defining KPIs is about, let's say, roughly 15 to 20%. Most of the time is optimizing the algorithm, and a bit of time is left over for the other pieces. Does this look about right? Okay. This is the reality. So the reality is you don't spend that much time defining KPIs because, as I'm sure many of you know, the biggest difference between software engineering, software development, and machine learning is software development and engineering is a lot more like math. You're proving something. You're saying this is going to work or it's not going to work. In machine learning, you're constantly running experiments. And so you have to be very agile, not in the way that we used to be agile with product development. You have to be agile in deciding when you're going to kill an experiment and move on to the next one. And so you see that KPIs is actually a short period of time and resource allocation because you're going to have to do it over and over and over again. Collecting data, I would argue it's actually bigger than this. It depends what you're working on, but in my experience, that's where I've spent most of my time. Building the infrastructure is something that I can't reiterate. Like, there's a lot of discussion about how machine learning is automating software engineering, and yes, it's happening. The job description of every software engineer at Google, and I think that's about 30,000 people, is going to fundamentally change in the next 3 to 5 years. But in the meantime, we need a lot of front-end and back-end engineers to basically hug this algorithm into a product or a service for customers. And optimizing the algorithm is a sliver, right? It takes almost no time at all. And we can talk about this maybe in the panel as well. I have very strong feelings about companies building their own algorithms. I really don't think it's usually a good way to spend your time or your money. Often, to be able to build your own algorithm, you have to hire a data scientist who can cost upwards of $200,000 to $250,000 a year. Most of the things the world is going to work on is going to be leveraging things off the shelf. Leveraging pre-trained algorithms, and the people that you need to hire are the people who understand how to bring it together, not how to build these fancy algorithms. And just maybe to finish that point off, and then we can move to the next slide, is I was talking with someone, I'm not sure if he's in the crowd now, who has a PhD in neuroscience machine learning and wants to join the Google Brain team, and I'm a huge supporter. He was talking about interpretability. How many of you are familiar with the term interpretability? So interpretability is basically the concept of being able to explain what is happening with an algorithm, so sort of coming back to the black box. If you have complex algorithms, you cannot explain them to your customers and your partners. And so in many cases, what I end up doing with the startups I work with is help them simplify really complex algorithms into simple regressions so that they can just get a product out the door. So I mentioned customers, partners, but also regulators, right? You need to be able to explain what's happening there. So just sort of reinforcing this. Feel free to take a picture of this. We're actually going to share it publicly. I have approval to do it. I won't run through all of them, but basically we stack rank the top 10 pitfalls that we're seeing startups and companies make from thinking that training your own ML algorithm was going to be faster than writing software code. You haven't collected your data. You thought that you were only going to train your model once. You'd be surprised. Like, this actually comes up again and again, and this is geographically distributed from Bangalore to Sao Paulo to Tel Aviv, Beijing, you name it. So this, I don't have that much more time, but just want to talk about the work that we're doing at Launchpad Studio. So basically, when I joined a little over a year ago, I was tasked with coming up with a hypothesis of how Google could support these companies that were having so many problems applying machine learning in their products. And we came up with two theses. One is that ML has a product problem. So, all the way from product managers not knowing enough about machine learning to know what's possible with it, to data scientists just wanting to create beautiful algorithms and not necessarily solving problems. The number of companies I've worked with who aren't solving a problem is astonishing. And so that's the first thesis. The second one, and Google has a role to play in this, is I believe I saw a stat recently, 75% of the world's AI talent is concentrated in Google, Facebook, Amazon, Microsoft, and IBM. And they also hold teaching jobs. So one of the things that we thought a lot about is how can we give access to startups to Google's talent? And so what we did is we built Launchpad Studio. Our first class was focused on the applications of AI in healthcare and biotech. We just announced a class focused on blockchain and fintech. And basically what we do there is we pick companies from all over the world, we bring them out to Mountain View in San Francisco, and they basically spend time with the world's top minds who are applying machine learning. And as I mentioned earlier, we've actually are bringing a lot of that talent and that know-how all the way to region now as well. So you don't actually have to get admitted into the studio program to get access to all of that magic. So one of, just with a bit of the time that I have left, this is a quote by one of my favorite people. He's been involved in Launchpad for a really long time. If you want to know more about AI, I'd recommend reading his book that he co-published with Stuart Russell. It's the book, if any of you have studied AI at university, that is used. And one of the things that, he's very involved in everything that we do, and he said, the software industry has had 50 years to perfect a methodology of software development. In machine learning, we've only had a few years. And so, a lot of what we're doing basically together is trying to build methodologies for startups. And so here again, feel free to take some pictures if you'd like. Here are some of the challenges that we're seeing startups have, not just when building a machine learning model, but across every aspect of their company when it comes to working with machine learning and AI. So, address some of these in our ML surprise slide. But if you think about products, so much of what I see as issues in scaling machine learning companies is getting software engineers and data scientists to play nice with each other. So going back to the mathematicians versus the scientists, like software engineers, most of our product managers at Google are software engineers, and they have very specific ways that they think about releasing code. When you introduce a few data scientists to that team, or people who have been upskilled in machine learning, they're artists. They're scientists, and they're in their lab running crazy experiments. It's very, very hard to get those people. They're writing code in different languages, right? Some of them are writing in Python, some of them are writing in R. How do you get these people to organizationally and culturally be nice to each other and actually build great products is a huge thing. From a design perspective, we talked about interpretability, but also the need for new user interfaces, being able to include your user maybe in your tagging system. So let's say you have a medical imaging product in the healthcare space. How can you build a user interface to empower your doctors to label your images for you so that you don't have to ship them out to India and do it with people who aren't trained in the medical field? There's a lot of thoughts around that. People hiring, retaining talent in this space, developing a data-aware culture across your entire company, not just in your product and engineering teams, because if you're going to be, the company of the future is going to have marketing, sales, HR, everything is going to be integrated and be data-driven. How do you prepare for that? And then finally, growth. How do you pitch an AI-powered company to a VC? I'm not going to go into that, but there's a reason why I left venture. There's a lot of money there, but I would say, maybe just as a piece of advice from an ex-VC perspective is think really hard about who you take money from when you're building something that is as sort of forward-looking as you're planning. These people are joining your team. I would really recommend against taking dumb money, as we call it in Silicon Valley. There's a lot of money chasing AI, but yeah, how do you actually get the money from the VCs that you need on your team to succeed is my point here. Marketing, pricing, you name it. And then one final thing before I leave you, I want to point you to a resource that I didn't mention earlier that we recently launched, so with Peter Norvig, who I mentioned earlier, as well as this amazing woman called Cassie Kozyrkov, who's also at Google. What we're doing here is we're working with our startups in our programs as well as the mentors in our programs, and they are writing case studies of what they're trying in applying machine learning. So their mistakes, the things that are working well for them, and our hope with this blog is to actually empower a whole community of people to share methodologies and best practices. Because one thing that we're really conscious of at Google is we don't even know what we're doing. I mean, don't worry too much, we know what we're doing. But we have a lot of challenges as well. And so we want to come with a lot of humility to this space and to building these ecosystems and basically say, hey, we don't have it all figured out. Tell us what you're trying. Also, tell us what you're trying with 100th the amount of data that we have, right? You need best practices for all sorts of use cases and environments and products that you're trying to build. So yeah, I think that's it for now. I'm going to be joined by some awesome founders.
All right. Thank you very much, Malika.
Thank you.